Hi guys, my name is Esther from Allison Tutors. Today I'll be presenting on grade 9 algebraic equations and expressions. I've taken these questions from various 2024 papers. I'll also attach a link to our study library, then you can also access this paper. Okay, so we can start then. So question 1 says to simplify 100p to the power a or raised to the power b, what do we do? Now in this particular case, you're going to multiply these two exponents, the a and the b. So it's basically multiplying the exponents, which is c. Okay, let us go on. Question 2. You're being asked to evaluate the following: 4 over 5x minus 1 over 3x minus 1 over 15x. Okay, here's how you're going to do the calculation. Just give me 1 second, please, to write it on my whiteboard, then I can explain it for you. Okay, so firstly, you're going to have a lowest common multiple for 5, 3, and 15. Now, in this particular case, what's going to be your lowest common multiple? Your lowest common multiple here would be 15, right? So your lowest common multiple is going to be 15. Okay, what is 5 into 15? 5 into 15 is 3. 3 times 4x is 12x. Then you say minus. What is 3 into 15? It's 5. 5 times minus x, that's 5x. What is 15 into 15? It's 1. 1 times minus x, that's minus x, right? Now, 12x minus 5x minus x, that gives you 6x over 15. Make sure that you reduce it to the lowest common terms. And how do you do that? You divide it by 3 over 3. Then you end up with 2 over 5x. Okay, so now this is the answer. So your answer in this case is going to come from B. Okay, now let us go on to the next part, which is question 3a. They said subtract 3a over 9 from a minus 9. You should be very particular, especially about the wording that they put. They're asking you to subtract 3a over 9 from a minus 9. So how do we do this? We're going to say a over 9 minus 3a over 9, and a minus 3a gives you minus 2a over 9. Now, which option is this on the multiple choice section? Is option B. Okay, let us go on to the next part. On the next part, they are asking us which equation shows the correct use of the commutative property. This is more of a theoretical aspect, right? But it's going to be A plus B is equal to B plus A. Okay, so we're done with the multiple choice section. Let us go on to the long structured questions. They said match column A with the correct result in column B and write only the letter of the correct answer. Now, 3a times 3p, that gives you 9p squared. Which answer is closest to 9p squared? It's 3 squared times p squared, right? Because if you say 3 times 3, you get 3 squared, and p times p is p squared. So 4.1.1 matches to C. So you put a C here. Now, 3 over p times 3 over p. Now, this is going to give you 3 times 3 is 3 squared, right? And when we have 1 over p times 1 over p, that gives you 1 over p squared, which is p to the power of minus 2. So it's going to be A. So 4.1.2 is A. Now, let us move on to 4.1.3. You've got 1 over p to the power of minus 2 times 1 over p to the power of minus 2 times 1 over p to the power of minus 2 times 1 over p to the power of minus 2. Now, I think for this one, let me actually do it on whiteboard. So we've got 1 over p squared times 1 over p squared. times 1 over p squared times 1 over p squared. Now, this ends up as 1 over p to the power 2 raised to the power of 4, right? Now, if we have got 1 over p squared, this is the same as p to the power of minus 2, and then you raise it to the power of 4. So in essence, if you actually try solving this, you get p to the power of minus 8. Now, let us look for something that is closest to this. Let us look for an answer that is closest to this. It's going to be B. So 4.1.3, you're going to put B. Let us go on. Prove the following. PQ is equal to Q over P to the power of minus 1. Now, we're going to start with the most complicated part and try and simplify it to the easier one. So we've got PQ is equal to Q over P to the power of minus 1. Now, P to the power of minus 1, so this is basically Q multiplied by 1 over P to the power of minus 1. If it's 1 over something, it's always going to be to the power of minus 1. So now this becomes Q times P to the power of minus 1 to the power of minus 1. Then you end up with QP, or basically your PQ. Okay, now let us go on to 4.3.1, right? Let us go on to 4.3.1 and attempt it. Now, under 4.3.1, you are given the following. We have got r to the power of minus 2, s to the power of minus 5, multiplied by r to the power of 4, s to the power of minus 2, over r to the power of 2, s to the power of 6, right? Now, when you have got two exponents with the same base, you add them. So it's going to be r to the power of 4 plus minus 2. Then you also have s to the power of minus 5 plus minus 2. Then you say over r to the power of 2, s to the power of 6. Now, r to the power of 4 plus minus 2, it's r to the power of 2. S to the power of minus 5 plus minus 2, you get s to the power of minus 7. Then you say over r to the power of 2, s to the power of 6. I hope this is understandable so far. Okay, so you cancel the r to the power of 2, you cancel the r to the power of 2. Then you end up with s to the power of minus 7. Now, when you're dividing two exponents, it's more like you have to subtract them. So it's going to be r to the power of minus 7 minus 6. Then you end up with r to the power of minus 13, which later on simplifies to 1 over s to the power of 13. Now this is the final answer. Okay, let us go on to 4.3.2. Now, under 4.3.2, you're given the following question. You have got 5p to the power of 0, p, and then plus 5q to the power of 0, p, over minus 2p to the power of 2. Now, p to the power of 0 is 1, right? Then you multiply this by p. Then you say plus. 5q to the power of 0 is 1 times p, that's p. Then you say over. This is going to be over minus 4p squared. Now, 5p plus p, this gives you 6p. And then you say over minus 4pp. You cancel the p, you cancel the p. 2 into 6 is 3. 2 into 4 is 2. So you now end up with minus 3 over 2p, like that. I do hope that this is understandable. Okay, now let us go on to the fifth question, which is actually going to be the last question that we're going to look at. Okay, so here is the fifth question. The first one says, given 108 x to the power of 3y plus 75xy plus 35x to the power of 4y minus 18, how many expressions are there in the expression above? So we've got 1, 2, 3, 4. It's going to be 4 expressions, right? Now, what is the coefficient of x? Let us look at the x. Is the if the expression with x is this one. Now, which other variables exist beside it? It's 75y. So the coefficient of x is going to be 75y. It doesn't necessarily mean that the coefficient should strictly be just a constant. 6.1.3. What is the degree of the expression in x? The degree of the expression in x, you take the highest power, and the highest power in this case is the fourth degree. Okay, let us go on to question 6.2. Now, you're given the expression minus a plus 2b minus 2a cubed, and you're asked to find the value of the expression if a is equal to minus 1 and b is equal to 2. So you've got minus a plus bracket 2b minus 2a to the power of 3. Now, in this case, we are saying that a is equal to minus 1 and b is equal to 2. And b is equal to 2. Okay, so you're now going to have minus, a is minus 1, minus minus 1, then you say plus bracket 2 multiplied by 2 minus 2 times minus 1, all raised to the power of 3. Now, minus minus 1, it gives you a positive 1. Then you say plus 2 times 2 is 4. Minus 2 times minus 1 is positive 2. And then you raise it to the power of 3. So you now get 1 plus 6 squared. If you punch it all into the calculator, sorry, 1 plus 6 cubed, if you punch it all into the calculator, you end up with 217. So 217 is going to be your answer. Okay, let us go on to the next part. You're being asked to simplify the following expressions. So here's how you're going to do it. So you have minus 3a bracket a plus b multiplied by 2a minus b squared. Now, minus 3a times a gives you minus 3a squared. Minus 3a times b gives you minus 3b, minus 3ab. So now what's happening is I'm specifically working with these first two terms. Then from here, I then go on and then I multiply it with 2a minus b squared. So you're going to say minus 3a squared multiplied by 2a minus b squared. Then you say minus 3ab multiplied by 2a minus b squared. So Minus 3a squared times 2a gives you minus 6a cubed. Minus 3a squared multiplied by minus b squared gives you positive 3a squared b squared. Minus 3ab times 2a gives you minus 6a squared b. Minus 3ab times minus b squared gives you positive 3ab cubed. Okay, so when you write it in full, it's going to be 3a squared b squared plus 3ab cubed. I just decided to group them, and start with specifically the positive numbers. Okay, so now this is the final answer. Okay, now let us go on to the next question, 6.3.2. So here's 6.3.2. So we have got 2x squared raised to the power of 3. And then we say plus the cube root of 27x to the power of 12 minus 8x to the power of 4. Now, 2 to the power of 3, this gives us 8. So we end up with 8x to the power of, you multiply these exponents. So you get 8x to the power of 6, then you say plus. The cube root of 27 is 3. Now, cube root is the same as to the power of a third. So if you have got x to the power of 12, and then you raise it to the power of a third, if you multiply the 3 and the third, you get a 4, right? Then you say minus 8x to the power of 4. So now this ends up as 8x to the power of 6 minus 5x to the power of 4. That's the final answer. Okay, now let us go on to the next part, which is more like the last part, where they talk about factorization of these expressions. Now, we have got p squared minus 25. Now, this is a difference of two perfect squares. The square root of p squared is p. The square root of 25 is 5. So you also have a p and a 5. So these are like in two different brackets. Then you put a plus and a minus. So you've now managed to factorize it. You can also use maybe like you're given a question like p squared minus 64. The square root of p squared is p. The square root of 64 is 8. So you've got a bracket where you've got p and 8. And then you also have a bracket where you have got p and 8. Then you put a plus and a minus. That's basically how it's done. Okay. Now, let's say you're given 3x squared minus 21x plus 90, then you're asked, plus 30, then you're asked to factorize it. You multiply these two extreme values, right? Then you get 90x squared. And then this number that is at the end, the minus 21x, remains constant. Now, which two numbers are you going to multiply to get 90x squared? And when you add them, you get minus 21x. Let us do like a trial and error. It can be, maybe you can choose 2 and 45, or minus 2 and minus 45, but definitely when you add them, you don't get minus 21. You can choose 3 and 30, as well as minus 3 and minus 30, but when you add them, you don't get minus 21. So let us continue going. You can also maybe choose 5 and 18, but when you add them, you don't get minus 21. You could also have 6 and 15. Well, with 6 and 15, when you multiply them, you get 90, but when you add them, you get 21. But definitely, if you say minus 6 and minus 15, you'll be able to get to satisfy the conditions needed. So you're going to use minus 6 and minus 15. So we now go on to say 3x squared minus 6x minus 5x plus 30. You factor out the 3x, then you put a bracket, x minus 2. You factor out the minus 5. Oh, okay. You factor out the minus, just give me a second, please. You factor out the minus 15, and then you have got bracket, x minus 2. So now when you factorize this, you're going to end up with 3x minus 15, close bracket, and then bracket x minus 2. That's the answer. Okay, so this is basically what we have in relation to algebraic expressions and equations. You could also check out more questions on our library site. I'm just going to share the link below, and I'm also just going to open the library link for you so that you can see how it works. So we've actually uploaded algebraic equations and expressions for grade 9. There are actually two worksheets with their answer with their memos as well. I think this should be very helpful. Thank you for taking time to watch our video and all the best.